Now, in order for us to talk about how osmosis affects a cell, we have to discuss what tonicity means. So tonicity is the measure of osmotic pressure between two solutions that's been separated by a semi-permeable membrane. Now, don't get caught up on that definition because it does sound like a pretty complicated definition. But to simplify things, it simply means that it's the ability of a solution to cause a cell to either gain or to lose water. So let's take a look at the types of tonicity that exist. Imagine a tank full of water, and inside this tank I add solutes such as sugar. So it looks something like this. The next thing I'm going to do is drop a cell in this tank. So it looks something like this. Now notice the concentration of the solute inside the tank versus that of inside the cell. So the solution in the tank has a higher solute concentration than that of the cell. All right, so now if I asked you, in which direction will water move? Take a moment and think about this. In which direction will water move? Well, water is going to move outside of the cell. Now imagine the implications of water moving outside of the cell. What do you think this is going to do to the cell itself? If water is being removed from the cell, how do you think this is going to affect the cell size? Well, the cell will shrink. So when water moves outside of the cell, it will shrink. Now, this is a situation where the solution is what's called a hypertonic solution. The prefix hyper means in excess. And the reason why it's used in this definition for this particular solution is because there is an excess amount of solutes when you compare that to the solutes found inside the cell. So now the system has reached equilibrium. Now let's imagine a scenario where I had the same tank, but this time I dropped another kind of cell inside this tank. But in this scenario, the tank solution has actually a lower solute concentration than that of the cell. So take a moment and think about which direction you think water will move in. So the answer would be water will move inside the cell. Now, as water is moving inside the cell, what kind of impact do you think this will have on the cell? Well, the cell will expand. And this can be a very dangerous situation for a cell because not only can it expand, but if enough water gets inside the cell, then it can compromise the integrity of the cell membrane and cause it to burst. So a cell that's placed in what's called a hypotonic solution runs the risk of bursting. Now this is called hypo because hypo essentially means less of something. And this would be less of a particular solute. So this would be a hypotonic solution. Now, I came up with this myself. I'm kind of proud of this because it's helped students in the past, and I hope that it helps you. A hypotonic solution causes a cell to expand. If you can imagine a hippo is a pretty big animal. And just like how this cell is a pretty big cell compared to maybe a hypertonic or cell in a hypertonic solution, I tell students when a cell is in a hypotonic solution, it will act like a hippo. So hypo-hippo might be a good way for you to remember that when a cell is placed in a hypotonic solution, it will always expand. So that's kind of just a memory trick. All right, here is another scenario where we have a cell placed in a solution where the solutes inside the solution and the solutes inside the cell are equal. So we have an equal concentration on both sides. So if I asked you which direction will water move, okay, maybe you were thinking that water might move in both directions. So it turns out that that's indeed the case. So water will move in and water will move out as well. So this causes the cell to stay the same as a result. And this is what's called an isotonic solution. It's isotonic, iso meaning that it's equal. So there's equal numbers of solutes on the inside versus that of inside the cell versus that of outside the cell. Okay, so remember that water moves in both directions equally. So water is coming in at the same rate as water is exiting. So you can imagine water molecule moving in here, and then another water molecule is moving out here, and those two molecules are canceling each other out so that there's no net movement of water. Okay, and those are all the types of tonicity. There's hypertonic, hypotonic, and isotonic, and how they affect the cell. So just remember that those three solutions are always in comparison to another kind of solution. And remember how the cell will react when it's placed in one of those three types of solutions. Now I will leave you with this question. Can you think of other places where you see osmosis taking place? So please think about that tonight, and when you come to class, we can discuss. So I hope that was helpful, and as always, keep up the studying.